right here we are looking at a Parrot AR drone. It's from the company Parrot, and it's a quadcopter drone. Okay, here's some. It has a foam outer body to protect the propellers, and then the actual computer is underneath. It also has a camera on the bottom here, and that allows it to take pictures of where it is and where it's going. So right now we're hooked up to the AR Drone 2 SSID, as you can see, and that's hooked up into this Kali Linux laptop, and it's using this USB alpha card. Okay, so this USB alpha card is connected to the AR Drone 2 Wi-Fi network, which is the Wi-Fi network for our Parrot drone, which is sitting on the floor. So now, if I use the Kali Linux ifconfig command, I see all of the wireless networks that I'm associated with. I see here that I am on a 192.168.1 network, and from there what I'm going to attempt to do is an Nmap scan to look for the IP address of our Parrot drone that is on the same wireless network as So right here, what I'm doing is I'm going to run a sweep of the network, basically a ping sweep of the network. So I took a common ping sweep script, and I modified it to do what I want so that I could build upon it. So what we're doing here is we're actually going to be scanning for anything that we think might be a drone. So let's just hit enter, and so already what we see is the 192.168.1.1 on the network that we scanned. Seems like it could be a drone. So what my script is doing is it's going to look for what we think are drones and what could be actual people controlling the drone. So right now, since we don't have anyone actually hooked up to the drone directly, all it's found is the drone, which is accurate. Okay, so again, experimenting with the Airmon NG, AeroCrack NG, AeroDump NG in Kali Linux. We're trying to use this alpha card to basically de-authenticate a user on the drone, and then drop the drone out of the sky again. However, what we're running into is any time that I do try to run the AeroDump commands on this machine, although it's finding data, it seems to be interfering with the other hardware on this machine. We're getting a device failed, device resource busy, error, and it looks like the green lights are off on my Alpha Networks card. So this method does not seem to be very successful compared to. So by using Nmap, we were able to determine that the Parrot drone was the IP address 192.168.1.1. So now what we did was ran a script scan for the top 100 ports on this system. We were able to determine that what is actually open on the Parrot drone is multiple ports. So as you can see here in our Nmap results, we have port 21 open, which is an FTP port running the BusyBox FTPD software. It's an IP camera that's built into the drone. And we have port 23 open, which is a telnet port, which we may be able to use to send commands to the drone. So let's look down a little further at our results and see if there's any other ports that are open. Okay, so these are just some tests that were sent to the telnet to see if anything else was wrong with it. There you can see the MAC address of the device. It's a Parrot. It comes back with the Parrot company MAC address, and it has a D-Link web camera associated with it. So now if I further enumerate the FTP service just by using FTP and the IP address of the drone, I get a connected and it says operation successful. So let's see if we could log in as an anonymous user. So we were successfully able to log in as an anonymous user. So the drone has anonymous FTP access, which is not the best idea. Let's just see if we can list the contents of this directory, and we can. We see the default directories with a police notice HTML file and a boxes directory. So maybe we'll change into the boxes directory and list the contents, and it doesn't seem like there's anything in there. However, if the drone user was taking pictures, we would be able to connect to this FTP server and see exactly what was being posted into this FTP directory as the drone was taking pictures in flight. Okay, so next we attempt to enumerate the telnet protocol that is also open on this drone, and then when we actually connect to that port 23, we notice that we have a BusyBox built-in shell, and we're actually sitting at the command prompt for that. So let's just see if we can type any commands. Yeah, so it looks like we have access to the operating system, the BusyBox OS here. So this looks promising. So again, from this telnet shell, we're able to access multiple directories. One of the directory is actually the factory directory, and it seems to have a bunch of different OS and application scripts in there, including possibly text files with more data that we can enumerate, such as the UID, the MAC address, and the serial number. So let's just take a shot at seeing if we can print out this MAC address file. Okay, and yes, so it does. It gives us the exact MAC address that we found with our Nmap scan. But we can dig through all these files to see what else is in here that might be useful. We do not, though, have write access to these directories, so we can further check all of these directories to see if there's anywhere where we can get some write access to maybe upgrade this user with an exploit. So from this telnet terminal, I was able to find a temp directory. So now if we do a command here, Okay, so what I'm doing is I'm typing a Linux command that will basically show us our permissions on this directory and any hidden files and some other interesting information for this directory. And as we can see here, this directory is writable. The dot at the top shows us that. So we should be able to, if there is some type of an exploit, we would be able to write to this directory. So now let's just continue to enumerate this file system to see if there's anything else we can do to exploit this particular OS. So after running the uname-a command, which gives us the operating system version, what we see is that this is running Unix UCL IBC 2.6.32, so we can start to look for exploits for this particular kernel, and that might give us a good starting point. So if I am a regular drone user, not a malicious user, what I can do is I can use this drone AR flight app, and I can run it on any tablet or phone, and I can fly my drone using this particular software. So just an example of how to do that, I'm just going to click on the Parrot AR Drone 2.0 free flight application, and all I have to do is click on the piloting button in the top left, and then what that'll do is that will activate a software link between my drone and the tablet, and I'll be able to steer the drone and fly the drone however I wish. So let's do that now. Let's go to piloting. Okay, so it's loading. Okay, so see right there is what my drone is seeing. This is the view from my drone's camera, and it's actually displaying right onto my Kindle Fire. So it has 68% battery life, and it's seeing what's over there. That it's seeing that box of diapers, basically. So the camera is on the edge of the drone. It's pointed at the purple box, and it's seeing the same exact thing in my camera right here. Alright, so looking back again at Nmap, what we did was we did the top 200 ports using the -st flag to the 192.168.1.1, which we had determined is the IP address that the drone is using as an access point, and we found that there's 3 open ports. We have 21, which is FTP, 23, which is Telnet, which we've looked at before and saw that we did have some type of shell, some BusyBox shell when we went into that with a Telnet client. And then there's another open TCP port, which is 5555, which is free CIV. I'm assuming the free CIV 5555 TCP port is for the app control, for the controlling of the drone through the app. And at the bottom we see the MAC address of the Parrot drone. Okay, so this time what I'm doing here is I'm actually using a netcat session. I did the NC command with port 23 to the IP address of the access point of the drone, and what we're doing is, again, we get the header back the banner BusyBox version 1.14.0, which is a built-in shell, which is Ash. Ash would tell us that it's somewhat of a limited shell, most likely. So let's try again and see what type of enumeration we can do and what type of additional information we can grab within this terminal. Okay, so I began to enumerate this Linux box to see if we could get somewhere with it to be able to run more commands or whatever we want to. And as I get through, I notice here that when I run the ID command, it actually is root. That it is a root account that's running this. So now my present working directory is the root. So let's look and see what else we can dig up. Okay, so when I cat the etc password file, what I see is these are all the different system accounts that are on this machine. So the next thing I tried to do was open a shadow file, cat out a shadow file, but it's telling me there is no such file or directory, which is interesting. We then go to just list the directory with the hidden files and folders as well, and you can see all the access permissions. So apparently we have access to pretty much everything we want to do. The next command that I'm running here is netstat with the antup flag, and this is the results right there. This is basically everything that's connected to the box or any connections on the box, or the drone I should say. Okay, so the next enumeration technique that I used was to run PS on the box. So what we have here is a list of all the processes running on this particular drone, and probably if we figure out which function, which process is connected back to the user that is actually flying the drone, we would be able to stop the drone and basically shut it down. So the shell that we are in does not seem very limited at all. After running several different enumeration techniques, it seems that we have full root control as it shows over this. And so we can uname, you can just get a Linux version again, and so we can see the kernel right here, and we have full control of this machine. If we just wanted to create a file right here, we can do so. So just gonna create a file right here called mercy.txt, and then I'm gonna cat that out, or actually I'm just gonna list the directory. Okay, and you see right there we created a mercy.txt file right in the root directory. So we definitely have full control on this system, since this directory is only writable by the root user. So this is definitely full access just pretty much by discovering these hidden services on the drone. So you would be able to do this with any drone that was in your area. All you would have to do is connect to its access point. It will basically use its DHCP and assign you an IP address on its network, and you could then either netcat or telnet directly to port 23, and you'll have full control. Also, as we saw before, you could FTP to the machine as well. So that would also give you the ability to just upload malicious files, change out any of the camera files, or delete any of the camera files that were happening on that machine. So this drone is not very secure. Okay, so let's do some further exploration to see what else is possible. Okay, so to check out what we actually have available to us in this Ash shell running BusyBox, what I did was I ran the ls-la /sbin Linux command, and what it did was it listed out all of what I can basically do from here, all of my commands that I can use. So what I'm seeing here of what I can do to basically hack this drone is I can either reboot it or I can power it off. So let's do a reboot on it and see what happens to the user when we type reboot. Okay, so typed reboot into our terminal, and we are the root user right now. Now this is our real user who's flying the drone right now. So let's actually try this with the drone flying. So I'm gonna come in here as if I am the user. Okay, I'm gonna press takeoff. Okay, now as you can see here, my drone is actually flying. So that's flying in the center of this room right here, as you can see. Okay, and here I see exactly as my drone is seeing. Now I'm gonna, in mid-flight, telnet it into this box as the root user. I'm gonna shut down, I'm gonna reboot the machine. I'm gonna watch what happens to the drone. And as you can see right there, we actually took the drone right out of the sky, and right here on our controller it says controller link not available. So right there is a successful hack of the drone just by using pen testing and enumeration techniques with Kali Linux. So just to do some further exploring of the drone, using my ifconfig command, I'm able to determine that my IP address for my high-powered Wi-Fi USB card, my Alpha Networks card, is 192.168.1.2. So that's WLAN 0, and we're going to use that to see what we can do using some of the other built-in Kali Linux tools to explore our AR Parrot drone. So basically this USB Wi-Fi card is still, it's not reacting to the computer. It's not showing up in my IF config any longer. The benefit though of using this USB Wi-Fi card in the last attack is that we would get a greater range on the Wi-Fi with this antenna hooked up to this powerful Wi-Fi card. So what would happen there is no matter how far that drone was flying, as long as it was in range of that USB card, we could use the same techniques that we previously did, and we'd be able to telnet in and either look at the images that the drone is taking, or we can upload malicious files using that FTP server, and we can also just drop the drone out of the sky, just the way that we did. So there's a lot of options, and it's definitely better to go with the more powerful card. Now, the second technique using this wireless suite of tools, the Aircrack NG, the AeroDump, and the Airmon NG, is not currently working with this laptop. There may be some sort of conflict with the existing Wi-Fi card and this USB device. I may one day try this again with a Raspberry Pi, but for now I'm recommending to stick with the other attack and see if you can expand upon it. There's probably a way to do this easier if you don't have another Wi-Fi card attached, because it's not gonna conflict. There may be some issues directly with that script, since it is suggesting that there would be an issue considering the other Wi-Fi card. Okay, so thanks again to Mercy College for providing access to the Metasploit Pro Edition for this project. And what I'm doing here is I'm using Metasploit to set up a multi-handler. My specific payload for the multi-handler is going to be the Linux x86 shell, reverse TCP shell. So what I have here is I set my local host for the IP address of this attacker machine, and just a standard port that would be used for reverse shells, which is 4443. Usually use 4444, but you could use 4443 or 1337 or any port that's not being occupied. So again, back here onto the victim drone machine, what I found was they're running Netcat. So if I really did want to break out of that Ash shell, all I would have to do is then just run back this Netcat command to the IP address of my attacker machine with the port I specified from my multi-handler, and then I would just send the /e switch with the bin shell executable. So here I'm going to exploit the multi-handler. So I typed exploit here. What this is going to do is it's going to start a listener and wait for me to execute this command here. Okay. And now, as you can see, I've opened a shell. If I type ID, it shows that I am root. Okay, so that was a successful attempt. So we basically have we pretty much have full access to that machine. We can do whatever we would want. We have an open session in our Metasploit, and we're out of the Ash shell. We're using just the standard shell. I did see if there was any bash on this machine. There is no bash. we could try to exploit further, maybe try to get that password file and the shadow file, which we've already saved the password file, but we'd want the shadow file as well. But we pretty much have everything we want on this machine. All the pictures of the drone that the drone has taken, we can add pictures to it if we wanted to. We could add exploits to it. We've gotten out of the ASP shell. It's pretty much completely compromised.